Good evening, everyone. Welcome to BYJU'S exam prep. So, I'm here again to discuss the questions of EMFT. There are some questions which were left yesterday, so we will continue that and and we will continue the session to the next chapter, that is your transmission line. So quickly share the session with all of your friends because it is going to be a important session. So I am sharing in my group. So you can also share with your friends and your any Telegram group or any WhatsApp group wherever you can share. See, the number of students are joining. Yesterday also the number of students has joined and they have got benefited from the overall session because they learned many things. What the mistakes that they are doing, resolve that. Okay, that they rectify. They understood that where they are doing the mistakes. So when you attend this type of session live, then not only you solve the problems and with me, but also you point out your mistakes. You get your mistakes where actually you are doing the mistakes. That mistakes you recognize, and that mistakes are allowed to do here, but you are not going to do that mistake in the main examination, right? So that is why these type of sessions are important for all the students. So don't think that it is a textbook solution, so it is not required, right? Every session is important that we bring for all of you because we usually bring the sessions for your knowledge, and that is these sessions are not generally for the sake of the taking the session. Most of the session we take are usually conceptual and important and focused to the exam. So please continue the joining the session. Okay, so let's start the session with the brief introduction about myself. If you are not aware about me, so guys, this is Saket Verma, and I have done MTech from IIT Guwahati and cracked the many PSU exams. I have cracked exams like Airport Authority of India, DRDO, and Bharat Electronics Limited, and there is a vacancy, huge vacancy for the electronics engineering students for BEL, and I'm having more than 13-year experience. My area of expertise are these electromagnetic theory, communication system, advanced communication system, signals and system, etc. You can also join my Telegram group if you need a PDF of the session with the solution, because whatever solution we will do here, the same PDF I can share with you if you join this Telegram group and connect with me, if you tag me and ask me for the PDF. There is a open all India mega mock test. This is for all the branches, not only for mechanical. It is for mechanical, CS, EC, EEIN. So you can attempt the all India mock test for free of cost, and the link is given in the description. So guys, this is the first question of the today's class, and let's see that how many of you know this concept. And I'm giving you 5 minutes to solve this problem, and I'm also coming with the answers. That what are the answers there? So let me find out the answers because this is the textbook question. So I have the answer key with me. Answer key is sufficient because we will solve the question. We will match our answer, right? We don't need solution because we are going to solve it very in a very good manner. So come on, guys, quickly solve this session question. So just do the comment in the comment section once. Okay, just do the comment in the comment section once. When you do the comment in the comment section, I will understand that how many of you are live and going to solve this problem along with me. Yes, Vinod, good evening. So solve this problem. Yes, Reshma, hello. So can you solve this problem? An electromagnetic wave travels in a free space with the electric field component 100 e to the power j 0.866 y plus 0.5 z. Yes, Rajesh, this is for the electronics engineering. This is not for the electrical. All the electronics, how to prepare EMFT for easy way. See, and if you want to prepare the electromagnetic theory in the easy way, then you should join our crash course because in our crash course I have covered the EMFT in the very precise manner. Within the 20 hours, you will be able to solve the maximum question of EMFT. I cannot say all the questions, but yes, 80% questions you will be able to solve if you attend that crash course. I don't have any course in the YouTube, so I cannot, ask you to join that particular session or see the recorded lecture. But the four important chapters that you should cover if you are preparing by yourself, then four important chapters are there that you should cover. That is your plane wave propagation, transmission line, waveguide, and antenna. If you are from electronics, then these four chapters you prepare. That is the least burden you will have in terms of syllabus, and you will cover the almost 70 to 80% of syllabus, entire syllabus, and there will be a huge chance that you will score maximum from the subject EMFT. Okay, so you have completed with the recorded session. Then what are the problem you are facing to solve the questions? Last 30 seconds. You have to find omega, lambda, the time average power and magnetic field. Problem to solve the problem in easy way, you have to practice a lot because this is all about the maximum formulas are there in the MFT and concepts are also there, but if you know all the formulas, you will be able to solve 40% questions. 40% questions comes directly from the formula, and the remaining 60% question come with the formula with the concept. So if you want to score maximum, then at least memorize all the formulas that is important that you have seen the recorded lecture, then you are aware about the all the important formulas. So just go through all the important formulas, you will be able to cover the 40% of the whole EMFT. Okay, and then concept, to get the concept and formula questions, you need to attend all the important sessions that we take in the channel, and also you practice from the test series. Okay, then you will be able to solve this. So now let's solve this problem first, because those who have solved, anyone can give the answer. So we know that if the this is the suppressed electric field, then it can be represented as E naught e to the power j beta. Here we will say the k dot r. right? Here we will say the K dot R. So if I compare it, then what I can see is this expression. If I compare this expression, if I compare with this, then what I see is the K dot R is 0.866y plus 0.5z. Okay. Now the vector K is equal to 0.866 ay and 0.5 az. This 0.866 is nothing but the root over 3 by 2 we can write. Okay, and this 1 by 2 we can write. Now you should know that this is the propagation vector. So the magnitude of propagation vector is nothing but the beta of that medium. So beta is magnitude of vector k. So root over 3 by 2 whole square plus 1 by 2 whole square. This is 3 by 4, 1 by 4. So this is 1 radian per second. So you are getting the beta as 1 radian per second and the electromagnetic wave is traveling in the free space. So if the electromagnetic wave is traveling in the free space, we know that this beta is given by omega by c if the wave is traveling in the free space. So the beta we have calculated as 1. So now omega is equal to beta into c, which is 3 into 10 to the power 8 radian per second. So this is the answer of the first question, that is omega. Now what about the lambda? This is the first part, and the lambda is nothing but the 2 pi by beta. Beta is 1, so this is 2 pi. So you can say that the lambda is 6.28 meter. So this is the second answer we have. Okay. So now we have got these two answers. First answer is your omega, second answer is lambda. Now coming to the magnetic field component. How can you calculate the magnetic field component? Okay. How can you calculate the magnetic field component? That is nothing but the K cross electric field upon mu omega. Okay, magnetic field is K cross E upon mu into omega. Because it is free space, so mu naught we will get. What is the propagation vector? The propagation vector we have calculated as root 3 by 2 ax ay and 1 by 2 az. Okay, this is the K. Cross electric field. Electric field is 100 e to the power j 0.866y plus 0.5 z and ax. So because all these are constant, it will be 100 e to the power j 0.866y plus 0.5 z will be outside and mu naught will be there. Now we are going to take the cross product between this root 3 by 2 ay cross ax is minus az. So root 3 by 2 minus az plus this az cross ax will be ay, so this is 1 by 2 ay. This you will get. So now in this way we will get the magnetic field as mu naught. You can substitute the value of mu naught and omega. Yes, omega we forgot now. Mu naught into omega we have not written. Omega, yes, omega is also there now. Mu naught omega. So when you will calculate this, 100 upon 4 pi into 10 to the power minus 7 and 3 into 10 to the power 8, that is our omega, and e to the power j 0.866y plus 0.5 z, and it is minus 0.866 az plus 0.5 ay. Okay, so what you are getting? Can you tell me what you are getting after solving this? So if I solve this, it is 10 raised to power 8, 10 raised to power 7. So 10 cancel. This will cancel and the 10 will be left. And this 0 and this will cancel. So 10. So 10 upon 10 into 0.866 divided by 12 pi. So 0.299. So we are getting minus 0.229 AZ cap plus 0.5. 0.133 A y e to the power j 0.866 y and 0.5 z. Mm, 4 pi we have got to write it. 4 pi into 10 to the power 7. 10 is left. Okay. Mm, let me check once again. 0.866 into 100 divided by constant 33 into omega c into 10 to the power 8. 0.229, yes. Okay, so this will be our answer for magnetic field. Now, what is the second? This is the second part, right? This is the second part. Now, what is the third part? Third part is the time average pointing vector we want to calculate. So, time average pointing vector is power density, which is E naught square upon 2 eta and the direction of propagation. So E naught square, that is 100 square, divided by 2 into 120 pi and the direction of propagation. So the propagation vector is 0.866 AY and plus 0.5 AZ, and this will be watt per meter square. So let's check what we are getting. 11.48 AY plus 6.63 AZ. So this we should get 11.43. Yes, 6.63 AZ. This is the right answer. Okay, this is in watt per meter square. So this is the third part. Got it, everyone? Is it clear to everyone? Just let me know. Okay, now solve this problem. So the amplitude of a wave traveling through a lossy non-magnetic medium reduces by 18% every meter. In every 1 meter, it is reduced by 18%. And wave operates at 10 megahertz, and the electric field leads the magnetic field by 24 degree. That means the angle which is given to us is theta eta, and okay, okay. There was a one relation that we derived yesterday. If you remember, then if you have attended the last class, then definitely you will be able to solve this question. Yes, you have 2 minutes more to solve this problem. The propagation constant means gamma, the wavelength means lambda, skin depth means delta, which is 1 upon alpha, and the conductivity of the medium, that is sigma. These are the parameters that you have to calculate. So it is saying that in this question, it is saying that the amplitude is reduced by 18% every meter. That means 18% reduced by 18% means it will be left with the 82% of maximum value, and this is E naught e to the power minus alpha into 1, because every meter, so that is why Z is 1. So this E naught is cancelled, and when we take the natural log, it is 0.82 and natural log of e to the power minus alpha. So wavelength you are getting 20, skin at 5.26. Okay, let directly you are calculating these things. So alpha is nothing but a 0.198 Napier per meter. So 5.03 is the skin depth. Okay, so first of all, I will calculate the alpha. Now I have to look for the beta. How can I calculate the beta? Because the alpha I have calculated, I am calculating the first part. So because I know the relation between alpha and beta, it is nothing but a tan theta by 2. Okay, and this angle is nothing but the theta eta. In this question, this theta eta is 24 degrees. What is the relation between the theta eta and theta? So this is nothing but your theta eta is equal to 1 upon tan inverse of tan theta. So that means theta eta is equal to theta by 2. So theta by 2 is tan theta. So this is tan 24. So beta is equal to alpha upon tan 24. Okay, alpha is 0.198 divided by tan 24. So the finally value of beta is 0.198 divided by tan 24, and we are getting 0.44 radian per meter. So this is the second value which I am getting. Okay, so now my first question, answer of the first question is the gamma. Gamma is equal to alpha plus j beta, and alpha is 0.198 plus j into 0.44 unit is meter inverse. This is the answer of the first question, right? Now I have to calculate the wavelength. So the wavelength is the second part. Wavelength is lambda. Lambda is equal to 2 pi by beta. So this is 2 pi divided by 0.444. So 2 pi divided by 0.444 is 14.15 meter. That is your wavelength. Okay. Now skin depth. Skin depth delta is nothing but the 1 upon alpha. So 1 upon 0.198, 5.05 meter. And the last part is conductivity. Conductivity, because the tan theta is equal to sigma upon omega epsilon, and omega we know what is the sigma upon omega epsilon, we can directly calculate. Conductivity, the conductivity we have to calculate it by, first of all, we need to calculate the epsilon r also, na? Because sigma we want tan theta. Okay, we can write this 2 pi f naught into epsilon naught into epsilon r. What about the epsilon r? So to get the value of epsilon r, we need to use the value of alpha, which is omega by c root over mu r into epsilon r divided by 2 in bracket root over 1 plus sigma upon omega epsilon whole square minus, okay, and sigma upon epsilon naught is uh, the theta is 20, theta eta is 24, right? So theta is 10 in 12, 10 12 is 0.212. Okay, we know that this tan theta is sigma by omega epsilon, and theta is how much? Theta is theta eta we have na. So theta is 48. Okay, so 1048. So this is 1048. So what is 1048? 1048. 1.1. 1.1. So 1.11 we are getting because the theta is 48, not 12. 48. Theta is 48. So now we will substitute all the values. So 0.198 equal to omega. What about omega? So 10 megahertz is given. So 2 pi into 10 to the power 6 divided by 3 into 10 to the power 8. Here mu r, it is non-magnetic, epsilon r is 1 root over 1 plus 1.11 whole square minus 1. Can anyone calculate the epsilon r for me here? 10 to the power 7. So here we get 30. So it is 5 now. So it is 15. 15 into 0.198. 0.198 into 15 divided by pi. If I square it, I will get this. And epsilon r divided by 2 in the root, we will get 1 plus 1.11 whole square minus 1. Okay, can anyone calculate the epsilon r? 3.63, yes. So 3.62 I am getting. Actually 3.62. Epsilon r 3.62. Where you joined? Uh, you have already listened. Now you joined. You said I didn't understand your meaning. You have already seen all of the lectures. Have you already seen all the lectures? So 3.62 we are getting, and epsilon r we need. Now we will substitute this epsilon r in this equation. So we will have to calculate this sigma. So now the sigma is tan theta, which is 1.11 into 2 pi into f, which is 10 raised to power 7 because megahertz, and epsilon naught into epsilon r, which is 3.62. So the sigma is 1.11 into 2 pi into 10 to the power 7 into epsilon naught into 3.62. So I am getting 2.2 into 10 raised to power 3. 2.2 into 10 raised to power 3, 2.2 into 10 to the power minus 3 Siemens per meter. This is the answer. Okay, okay. Great. So in this way, we have learned how to solve this type of problem. So all the 4 problems we have solved. Okay, now try to solve this question. So I'm giving you again 5 minutes to solve this problem. Let me see that how many of you can solve this problem within the time limit. Seawater plays a vital role in the study of the submarine communication, assuming that the seawater sigma is 4 Siemens per meter and epsilon r and mu are also given with the frequency of 100 megahertz. Then you have to calculate the phase velocity, wavelength, skin depth, and the intrinsic impedance. Come on, anyone who has solved the answer? Anyone who has solved the answer? Anyone? Epsilon not constant value. Okay, you don't know the epsilon not constant value. So first of all, you have to understand that whether this medium is a conductor or lossy dielectric, because well the sigma is greater than 1, so there is a chance that it would be a conductor. So we will check first, because before applying the formula we have to understand which is the what is the medium. So we will calculate the sigma upon omega epsilon. So sigma is 4 and omega is 2 pi into f. F is your 100 megahertz and epsilon naught is 80 and epsilon r is 80 and epsilon naught is 10 raised to power minus 9 divided by 36 pi. So 2 pi and this will get cancelled, you will get 18, and after solving this overall, because we have a calculator so no need to approximate it, we can directly calculate directly 10 raised to power 8 into 9. Actually this will all get cancelled now, so we have to just divide it by 8. Yeah, we are getting 9. It is given 81. Okay, 10 is to power 8, 9, 10 is to power 9, cancel. This is 36, 2 pi, and this is 18, and 4 to 9. So we will get 9. 80,000, 9,000 years should get actually. 2 pi into 10 is to the power 5. Okay. Okay. So we are getting this values, right? So because it is greater than 1, we will take it as a conductor, and if it is a conductor, we will assume the medium is conductor. Okay, we will assume the medium is conductor. So because the medium is conductor, we will calculate the Vp. Vp is equal to omega by beta, and it is 2 pi into f. F is 10 to the power 8. Now you have to calculate the value of beta. So how will you calculate the value of beta? Beta and alpha both are same, which is omega mu sigma upon 2, right? Or you can say this is pi f mu sigma. So the value is root over pi into f into mu. Mu are 1 into sigma 4. So 39.73 we will get. 39.73. Okay, so 39.73 we are getting. Now we will substitute this value 39.73. So it is 2 pi into 10 to the power 8. 39.73 we are getting as 115.8 into 10 to the power 6. 15.8 into 10 to the power 6 we are getting. Okay. So and now you can calculate the wavelength. Lambda is equal to C by F, Vp upon F, and skin depth is delta is equal to 1 by alpha, and interesting impedance is omega mu upon sigma root over it. So omega mu upon sigma I will calculate here. Omega is same, 2 pi into 10 to the power 8. Mu is mu naught, and f sigma is 4. So root over 2 pi into 10 to the power 8 into mu naught 14.4. So 14.04 ohms we are getting. Very small value we are getting, 14.04. And the angle will be 45. Because it is a good conductor, so the angle will be 45. So this would be the answer for this question. Now try solving this question. Which question number is this? Alpha is given, beta we want to calculate, certain medium is not given. Hmm. So in certain medium is not given. It can be any medium. You have to identify the medium, and according to that you can apply the formula. So last 20 seconds. Okay. See here what you have given. Note all the important points over here. The magnetic field, all these values are given. See, the medium, for the medium, these values are given, the magnetic field is given, the value of alpha given, omega given. So T is equal to 2 pi by omega. From here you can calculate the time period, which is the easiest part of this question. So pi into 10 to the power 8, pi and pi will get cancelled, and you will get 2 into 10 to the power minus 8, or you can say the 20 nanosecond. Fine. Okay. Now, the wavelength, if you want to calculate the wavelength, is given by 2 pi by beta. So, beta we want to calculate, and to calculate the beta, we need a medium. So, what we can do here, because the alpha is given, the alpha upon beta, we know it is root over 1 plus sigma upon omega epsilon whole square minus 1 divided by root over 1 plus sigma upon omega epsilon whole square plus 1, and the root over it, omega c, yes, root over it, yeah, the root over it. Now we have alpha. What is the value of alpha? Which is 0.1 and divided by beta. So let's take the square of it. We will get this one. Is there any benefit of doing this? Hmm. Think of it. What would be the benefit of doing this? If I divide it, root over this 1 by 2 omega c mu, everything we have, but alpha is equal to this, so we can do one thing here. Alpha we know, here sigma upon omega epsilon we don't know, so take it as x. Okay, do one thing. Before applying this, we know that alpha is equal to omega by c in bracket mu r into epsilon r divided by 2 root over 1 plus sigma upon omega epsilon whole square minus 1, bracket close, right? Alpha is given as 0.1. Okay, and omega is pi into 10 to the power 8 divided by 3 into 10 to the power 8. Mu r and epsilon r, mu r is 1 and epsilon r is 4. So 4 divided by 2, which will be 2, and root over 1 plus sigma upon omega epsilon whole square minus 1 bracket close, right? So this will get cancelled and we will get 0.3 upon pi whole square is equal to 2 in bracket root over 1 plus sigma upon omega epsilon whole square minus 1. So what we will get, point 0.3 square, 0.3 square divided by pi square, shift pi square into 2, okay, then plus 1, then square of it, then minus 1, then square root of it. So I am getting the sigma upon omega epsilon is equal to 0.095, which is less than 1. So we will consider it as a lossy dielectric. Okay, so the medium would be considered as a lossy dielectric. So now because we have got the sigma by omega epsilon, we can calculate the value of beta by the same formula, which is omega by c root over mu r into epsilon r divided by 2 in bracket. There is only one change, that is 1 plus sigma upon omega epsilon whole square plus 1. Okay, so this is pi into 10 to the power 8 divided by 3 into 10 to the power 8. Inside the root, there is a 4 divided by 2, 1 plus 0.095, 6 also I am considering, square plus 1. Let's see what we are getting. This will get cancelled. We will get pi by 3. So pi divided by 3 into root 2 into again root 1 plus 0.0956 square plus 1. 1.81. Let me check the value of beta. Yeah, it is somewhat 2.088. We are getting 1.81. 1.81. Okay, so the beta is 1.81. Now, once you get the alpha and beta, the things will resolve. So, with this part we have done. Now, the lambda is 2 pi divided by 1.82. So, it is 2 pi divided by 1.82. We are getting 3.45 meter. 3.45 meter is the wavelength. Now you have to find the electric field. So electric field, you need a peak value. You know the direction of propagation. So alpha will remain same and sine of omega will also remain same. Beta will also remain same. The direction of electric field. These two things we need to find. And for that we need to find the eta. So what is that eta? Eta is root over mu by epsilon in bracket 1 plus sigma upon omega epsilon whole square to the power 1 by 4. So from here you will get the value. Okay, you can substitute it 120 pi root over mu r. What is the value of mu r? Mu r is 1. So 1 by 4 you will get. So it is 60 pi 1 plus 0.095 whole square to the power 0.25. So what I am getting, let me check. It is 60 pi. It is 60 pi divide में आ जाएगा आपके पास 1 plus 0.095 square का power 0.25, right? So 188.07 आ रहा है. So eta we have got, but theta eta ये magnitude था. So 1 by 2 tan inverse of sigma by omega epsilon. So tan inverse of 0.0956 आया था 5.4 divided by 2. So 2.73 degrees. तो इतना सारा सब कुछ आ जाएगा. अब आपको निकालना क्या है? H E नॉट निकालना है. तो E नॉट से, ठीक है, वापिस आता हूं मैं इसमें. E नॉट से हमको आना है ईटा इंटू एच नॉट. तो ईटा है 12 एम्पियर में है. So 12 into 188.07 at an angle of 2.73, ये आ जाएगा तुम्हारे पास E नॉट का वैल्यू. सो 12 इंटू 188.07, तो ये आ जाएगा 2256. सो हम यहाँ पे लिख लेते हैं, ये आ रहा है 2256.84 e टू द पावर माइनस 0.1 y साइन ऑफ पाई इंटू 10 टू द पावर 8 t माइनस बीटा. बीटा इज 0.0 नहीं कितना था, 1.8 ना, 1.81 आया था. सो ये आया था 1.81 y, और ये एंगल जो आया आपका मल्टीप्लाई हुआ वो ऐड हो जाएगा 2.73 डिग्रीज. और डायरेक्शन निकाल लेंगे, डायरेक्शन ऑफ मैग्नेटिक फील्ड एंड डायरेक्शन ऑफ वेव प्रोपोगेशन. ये होगा डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. सो डायरेक्शन ऑफ मैग्नेटिक फील्ड x था, y है, तो ये z हो जाएगा. चलो ये हमारा फाइनल आंसर होना चाहिए. चेक दिस. किलो वोल्ट में निकालोगे तो 2.25. एवरीथिंग इज परफेक्ट, सब सही है आपका इससे. ठीक है, तो पूरे आंसर आ गए. थीटा ईटा, यही आपका थीटा ईटा है जो हमको निकाला था 2.73 डिग्री. ये जो आया है वही आपका फाइनल आंसर है 2.73. राइट. तो इस तरीके से आपको सॉल्व करना है. एनी डाउट इन दिस क्वेश्चन? Come on, tell me if you have any doubt in this question, solution of this question. You can check. Okay, anyone having any doubt? Yes, guys, quickly, any doubt? No? So let's move into the next question. This is the next question that I want you to solve. I think this can be done in the 3 minutes. If you are now solving it from the beginning, then you guys can solve in 3 minutes. Obviously, I will take time because I need to explain that how to solve this. So that's why I will take time, but you can solve it in the rough. So that cannot be taken too much time here. Yes, you have 1 minute 52 seconds now. Yes, the time up. Time is up, guys. So I hope that you guys have solved it. Okay. So in this question, it is given that the magnetic field component of electromagnetic wave, it is passing through the or it is traveling in the non-magnetic medium again. So this is mu r equal to 1. The direction of wave propagation. So from here we can see that the wave is propagating in the negative direction. So wave is propagating in the negative direction. We want to calculate the since the alpha is not present here, so we can say that it is a lossless medium. And if it is lossless, then we can write the beta is equal to omega by c into root over epsilon r. So root over epsilon r is beta into c upon omega. Beta is 6, c is 3 into 10 to the power 8 divided by omega, it is 2 into 10 is to the power 8. So it is 9. So if I square it, I will get 81. So epsilon r is equal to 81. We are getting this two part. Now the electric field, because it is lossless, the electric field component would be E naught sine of 2 into 10 to the power 8t plus 6x, and then the direction of electric field. So first of all, we will calculate the E naught. E naught is equal to eta into H naught. So we need a eta, right? So this eta you can calculate as 120 pi divided by root over epsilon r. So 120 pi divided by 9. Okay, so 120 pi divided by 9 into 25 into 10 to the power minus 3. So if I calculate it, 120 pi into 25 into 10 to the power minus 3 divided by 9 is 1.047, 1.047 volt per meter I am getting. So just substitute that, and the direction of electric field is again the direction of a magnetic field. Cross product with the direction of propagation, that is your direction of magnetic field is AY and the direction of propagation is minus AX, so it is coming as AZ. So final expression you can write. Let me tell you, 1.047 sine of 2 into 10 to the power 8 plus 6x and AZ volt per meter. Got it? Yes, 81. Yes, Rishit. Direction along the negative x-axis. Perfect. Now solve this one. A plane wave in air is traveling in the electric field is given. A reflected electric field we want to calculate. Assuming the copper is perfect conductor, copper slab is given. This is the oblique incidence question. Omega, okay, omega we will find it later on. It is not that important. The second part is most important because it is passing through the air. The second medium is a perfect conductor. What will be the reflected electric field? Can anyone tell? Okay, now to solve this problem, here you can see that if I suppose write this expression in the standard form, this is the incident wave. Okay, it is the incident wave. It is in air. So it is given as 8ax plus 6ay plus 5az, and the sign of in bracket omega t minus k dot r, incident propagation vector dot r. Okay, so on comparing, we will get ki dot r is 3x. If I take the minus sign common, then it is minus and it is plus. So the propagation is happening in the negative x direction, but in the positive y direction. So if I want to calculate, suppose beta of the incident medium, that is in the air, it is nothing but the magnitude of k. So it is 3 square plus 4 square, it is equal to 5. So omega is equal to beta into c. Beta is equal to omega by c. So beta into c, and that is 5 into 3 into 10 to the power 8. So this is the first answer, which was very easy. Now coming to the second part, which is the reflected electric field. So if I draw the diagram, okay, because the y equal to 0 is the boundary. Okay, y equal to 0 is the boundary. So this will be the y-axis. Y equal to 0 is the boundary. So the normal will be this one. And y greater than 0 is this part. So this is copper and this is air. Okay, so this is copper, this is air. So what will be this axis? This axis must be x. So the electric field should be in the negative x direction, right? So yes. So now we will incident this. We will incident. This is the air medium. Now we will incident this particular wave in this direction. So this is the incident propagation vector. Okay, why I am taking this? Because I am taking this as the x-axis, so this is the negative x-axis. So now if I incident from this side, so this will have the incident propagation vector in the y direction, that is the positive y, and this will be my x direction, which is negative x, right? Because in this propagation vector, we can see that this incident wave is having the magnitude magnitude 3 and direction negative x and positive y. So negative x and positive y you will draw, and because it is a perfect conductor, so it will reflect complete wave, and the reflected wave will have in the negative x direction, negative y direction. So the kr, when you will write the kr, it is in the negative y direction. So minus kiy into ay plus negative x direction. So negative x direction minus kix and ax. So actually it should be y component is having the amplitude 4. So it is minus 4ay. So minus 4ay minus 3ax. This will be our reflected wave. Now if I write the kr dot r, then it will be minus 4y minus 3x. So what will be the reflected wave? So reflected wave is E naught x, ax, E naught y, ay, E naught z, az, because it can have the all the three component, because incident wave is having the three component, and then sine of, just wait a second guys. Okay, so after this, okay, after this, the sine omega t minus kr dot r. Okay, so whatever we get here, we have fixed value. When you take this minus sign, so you will get plus 3x plus 4y. Okay, now we have to calculate this E naught x, E naught y, and E naught z. So to calculate this E naught x, E naught y, and E naught z, if we apply the boundary condition, okay, according to the boundary condition, because the second one is copper and copper is assumed to be a perfect conductor, so the electric field here should be zero. So if electric field is zero here, then the electric field in the first medium should also be zero. That means the tangential component. So ET1 is equal to ET2. So the tangential component in medium 1 is equal to tangential component in medium 2. What are the tangential component? Because the y equal to 0 is the boundary, x and y will be the tangential component. So the total x component is E naught x. Okay, total x component is E naught x ax plus E naught z az. These are the reflected wave tangential component. This is the reflected wave tangential component. And what about the incident wave? 8ax and 5az. So 8ax and 5az. This is the total tangential component in the medium 1. Medium 1 is air. Medium 1 is air. So the medium 1 is having the incident wave and the reflected wave. So this is the component of reflected wave. This is the component of electric incident wave. And in the second medium, medium 2, which is copper, there is no electric field. There is no electric field because the it is copper. So in the perfect conductor, there will be no electric field. So from here we can say that E naught x is minus 8 and E naught z is equal to minus 5 to hold this equation. So these two value we have got. Now we will apply the Maxwell equation. According to the Maxwell equations, okay, the Maxwell equation says that the Kr dot Er must be 0. Okay, so Kr is this one and ER is this. So when we multiply, this will be minus 4 E naught Y. Okay, these two will be multiplied and minus 3 E naught X. It should be 0 and E naught X we minus 4 E naught Y equal to 3 into E naught X. E naught X is minus 8, so that is E naught Y equal to 6, right? Because minus minus will get cancelled and 4 into 2 is 8, so 3 into 2 becomes 6. So E naught Z is minus 5 AZ. So this will be my reflected electric field. So here to solve this problem, you have to apply the two conditions, boundary condition and the Maxwell equation. Okay, then only you will be getting the right answer. Is it clear? Now this is one more questions that we are going to solve. This one would be the last question maybe. Okay, this is the question from the transmission line. This is very good conceptual question that we solved in the last class. Our last question was very conceptual. Now this is the easy one. Quickly solve this question. So guys done it? So have you guys done it? Okay. Okay, let's solve this question. This is the easy one because it is saying that it is a distortionless. So for the distortionless, the condition is R by L is equal to G by C. Okay, so this condition is satisfied, then only it will be called as a distortionless. And since it is distortionless, the alpha is given as root over Rg, which is 20 into 10 raised to power minus 3 milliampere per meter, it is written. And the Z naught is root over R by G and also equal to root over L by C, which is 60. So now if I multiply these two equations, I will get alpha Z naught is equal to R. So I can calculate the value of R by 20 into 10 raised to power minus 3 and 60. So it would be 1200 into 10 to the power minus 3. So it is 1.2. So 1.2 ohm we will get. Okay, now next value we have given is beta. Beta, no, Vp. Vp is equal to 0.6 into 10 raised to power 8 into 3, and this is equal to omega by beta. Okay, so now we get the beta is equal to omega, which is 2 pi into 10 to the power 8 divided by 0.6 into 3 into 10 to the power 8. So this 10 to the power 8 will get cancelled and it will be 2 pi divided by 1.8. So beta is this one 2 pi, or simply you can say it as a 10 5 pi by 9. 10 pi by 9. Okay. So 10 pi by 9 we are getting, and beta I said is given as omega root LC. So beta is equal to omega root LC, and we have Z naught is equal to root over L by C. So if I multiply beta into Z naught, then I will get L. Beta into Z naught is omega L. So L is equal to beta Z naught divided by omega. Beta is 10 pi by 9. Z naught is 60. Omega is 2 pi into 10 to the power 8. So pi and pi get cancelled, is 5, and this is 300 divided by 9 into 10 to the power minus 8. Okay, so 300 divided by 9 into 10 to the power minus 8. So we are getting around 333 in terms of Henry. If I, what you can do to calculate the other values, R and L we have calculated. Now G and C. Now you can divide these two, alpha and Z naught. So if you divide alpha and Z naught, so root Rg divided by root over R by G, so you will get G this time. Root R will get cancelled. So G will be alpha upon Z naught. Alpha is 20 into 10 to the power minus 3 and Z naught is 60. So it is 1 by 3 into 10 to the power minus 3. So this is another answer. Now we have got C. Now same, you can divide this beta and Z naught. So if I divide beta and Z naught, beta was omega root LC. This is root over L by C. So it is omega C now. C is equal to beta upon Z naught into omega. This was 10 pi by 9 into 60 into 2 pi into 10 to the power 8. So this pi and pi will get cancelled, 0 get cancelled. 1 upon 108 into 10 to the power 8. So now this one you can calculate. Okay. So 1 upon 108 nanofarad. So 10 upon 108 into 10 to the power minus 9. So 10 upon 108 is 0.09 into 10 to the power minus 9. So in terms of pico, if I write 92.59 picofarad. 92.59 picofarad will come. Hello, butterfly. Okay, guys. So thank you for watching this session. You are joining the session live. Uh, Late actually. So we will discuss the more questions tomorrow at the 10 a.m. morning. So you join tomorrow at 10 a.m. in this channel. I will clear all of your doubts. We will solve more questions on transmission line. So guys, we have launched the course for the 25 and 26. So if you are interested to prepare for GATE, then you can join our 25 and 26 batch, and the description is link is given in the description, and the contact number is this. So you can contact in this number. You will get every detail of regarding this batch, and you can also join my telegram group. This is my telegram group, and thank you for watching this session. Don't forget to subscribe the channel. Don't forget to download our BYJU'S exam prep app. The link is given in the description. Thank you. Yes, if you want to know the cost of the gate 2025, the contact number is given. You can contact in that number, and you can ask any doubt, every doubt regarding the batch. Okay.